Okay, good day to everyone. Today we're going to discuss the question and the answer for tutorial number 4. So let's see question number 1. Determine whether the following series has sum to infinity. Give your reason. Okay, so as for question A here, you can see 3 minus 2 plus 4 over 3 plus and so on. And then this one question 2 minus 6 plus 18 minus 54 plus so on, and 3 plus 7 plus 11 plus 15 and so on. Okay, look into question number 1A. The series has sum to infinity because it is geometric series. Okay, please look into this idea as it is geometric series with its common ratio. As we learned before, common ratio. How do you get your common ratio? Is going to get the second term divided by the first term. Okay, so negative 2 divided by 3. And if you want to write, use this one also can, 4 over 3 divided by negative 2. So you see that your ratio for the common ratio is negative 2 over 3, which satisfies negative 1 are less than 1. So satisfies this range. As for question B, the series does not have sum to infinity because its common ratio is r is equal to negative 3, which does not satisfy this range. Okay, as for question C, the series does not have sum to infinity because it is not a geometric series. This is not a geometric series. It is an arithmetic series with difference is equal to 4. The common difference is equal to 4. So actually this one is plus 4. Okay, plus 4. So next one, we go to next question. So this one, question 2, write down the terms in given series. Okay, so you can see from here, this one is sum. Okay, this one is 5, the r is equal to 2, this one is 3. So you can write in this, write down the term. So you have to write down the term. Okay, all right, write down the term 3 plus 3 plus 3 plus 3. Okay, so next one, this one, write down the term r is equal to 1. This one is 7. This one is negative 1. So replace r plus 1, r minus 1. So we have to write it, repeat how many times? So you can see 1, 2, okay, 3, 4, 5, 6, 7, 7 times, okay? They start from 1, end with 7. Okay, start from 1, end with 7. So we can change this one, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1, and 7 plus 1. After that, this one is the common, still remain 3. Yeah? Okay, and also the number inside here, you can see 1, 2, 3, 4, 5, 6, 7. And then you get this. This one is write down the term. Okay, be careful. They're not asking you to find the sum. They ask you to just write down the term. Okay, write down the term. Okay, so we move on to question number 3 here. Find the least number of the term required for the following arithmetic series. Okay, arithmetic series. So arithmetic is normally involve the difference, common difference, and series means that you are going to plus it. Okay, so to give a sum exceeding 3,000, exceeding 3,000 means that more than 3,000. So by using this formula, and then you find this answer, by using the factorization, you found your answer is n equal to 34.74. But we cannot get this number because the question asks for succeeding 3,000 and number of term is normally in whole number. So n is approximately 35. Okay, the 0 for 5n squared minus n minus 6,000 are these two answer, but we must get more than this number, then will be 35. So another, this one will be reject, okay, because we don't want a negative term, okay. All right, so we go for question number 4. The first term of an arithmetic series is 7, and its n term is 127. The sum of the first n term of the arithmetic series is 2077. So calculate the value of n and the 13th term of the series. So you can see from here, we can, from this phrases here, we can extract two important information. As for the first one is, you can see here, we substitute 7 into the formula and substitute this one into here. You will find out, you get your first one is, this is your first equation. This one is your first equation. This formula is to help you to find term, but we use it and we substitute it to get the first equation. But the second one, we need to use the sum formula. Compare with this one is a term formula, this one is a sum formula. That's why the formula that we use here is sum formula, and then you put into the 14, okay, 14, and then this one is 2, and then this is 2077, okay? All right, so you can get this one, okay? Because why you use 14 here? Because this given here is 13, okay? All right, so let's see here. The value of n and the 13 value. So let's see what I can, did I miss out anything here? Okay, good. So n over 2, 14 plus n minus 1 is equal to d. Okay, is 2077. So 14 plus 120 is equal to 2077. Okay, and then you found your n, you found your d. Okay, finally, with your n and d, you can find your term number 13 is this value. The value, final value is 55. Okay, come back to here. All right, the first term of arithmetic series is 7, and then the n term is 127. Okay, we cross check. We get this formula. Okay, the sum of the first n term of the arithmetic series is 2027. N term, calculate the value of n term, 13 term of the series. Okay. All right. You put into it here. Okay. This one 14. Oh, this 14 because it's 2a 7. So 2 times 7 become 14. Okay, 2 times 7 14, and then so on. You get this answer 14 here, and then move on here. Okay, t is equal to 13. Okay, all right, and then I just want to emphasize the 14 is from the multiplier is 2 and 7 from here. Okay, and then we move on, get 55 is the final answer for this question. As for this one, with the following geometric series, it means that it may involve multiply or divide. Find the least number of terms that must be taken for the sum of the series to be more than 200. Okay, so you can see here, the you found out that this one, 2 divided by 1, you get 2. So because since the r is more than 1, so it means that you use this formula. When we use this formula, then 1 is a is 1, the first value is 1, a, and then the n is 2 divided by 1, that's why you get 2. Or you also can use 8 divided by 4, you also get 2, or 4 divided by 2 also get 2, okay? So that's why your r is 2, n minus 1, 2 minus 1 is greater than 200, okay? So you found out that after you remove off this, n is greater than log 201, okay? You divide this one, okay? You're going to make them like this side, the value, okay? Then you get n is greater than 7.651, n is approximately at, okay? All right, this one is question number 5. And then question number 6, this one, express the recurring decimal 2.16. Okay, they actually have a dash here like this as a fraction as its lowest term. So you want to focus on this one. So 2.16. Let me write off this one. Okay, hold on. Let me write off this one. I write it like this only. 6 only. This value. Okay. Express the recurring decimal 2.16 as a fraction in its lowest term. So 2.16, there's one stripe on it. So 2.10 here, and then 0.06 here is 2 to the power 2 and 1 over 10 plus 0.0666. Okay, so this one 0.0666 can be expressed in a series of this value. So from here, this one look like infinity. So sum of infinity is equal to A. Your first value is this one. Remember, take the correct first value over 1 minus 0.1 equal to 1 over 15. Okay, so now 2.1, this one and subtract 6 here is equal to this value bring forward. Okay, this value bring forward. So you become a improper fraction look like this. Okay, all right. So this will be the answer for express the recurring decimal as fraction in lowest term. Okay, all right. So move on to this question number 7. A farmer has 18,675 apples. He saw 102 apples on the first day, and the following day he saw 3 apples more than the day before. After how many days will the apples finally sold out? So your difference is 3, because we can look at this 102 on the first day, day 1, and the following day is more than it. There will be 102 plus 3, become 105. And then day 3 will be 105 plus 3, 108, and so on. Each term is plus 3, plus 3. Okay, so you look into this situation. Okay, so D is 3, the difference, common difference is 3, the A is 102. You put into this formula, then you will find out, factorize it, you found 83. So after 83 day, the apples will sold. Okay, determine the number of apples sold on the last day. So you put this value 83 plus A plus 82D. Okay, so 82 is a n minus 1. 82 actually stand for n minus 1 D, so you get 348. So it actually means that 102, 105, 108 keep doing plus 3 plus 3 until at the end. On day 83, they sold out 348. So total up, sum up of this one is 18675. 18675 apple for the whole entire process. Okay, so on the last day, on the day 83, sold out 348 apples. Okay, we move on to question number 8. Okay, so we do the expansion. Okay, all right, this one is 4. This one here is a 4. All right, so we start from 0, 1, 2, 3, 4. Okay, start from 0, 1, 2, 3, 4. And then this one is your A. This one is your B. Okay, this one A4, B0, A3, B1, A2, B2, A1, B3, A0, B4. Okay, after that, we use the factorial method to find this answer. Okay, same goes to this one. Same goes to this one. We can have this. Okay, same method, move on this one. But it just that have to be extra careful with negative sign and the value that like this. Okay, so this question, you see the method that they use a bit different, as in here is your B. Okay, here is your B, and then you can use this method. This one is your here. Okay, and then you can factorize it out. Okay, factorize the common number here. Okay, 2 is taking out, 2 is taking out, and then they use this one method, this one, the formula. Why the formula is different from this formula? Because the value here is less than this one is another formula that we learned before this, not same as this one. Okay, so this one is in between -1 and 1. Okay, all right, so yeah, this formula, yeah, this is the one. Yes, so That's why you do like this. So remember, when you learn in our 4.4 and 4.5, you will get the idea as in this answer have to write in this one and the validity valid in this range only. Okay. All right. How do you get this one? Still remember how to get this one? Okay, it's from here. B. Okay. So let's say if -1 x 1. Okay. From B, this one. Okay. So you can recall this one by watching back the video that in 4.5 video, 4.4, 4.5 video, okay? And then we move on to question number 9. Okay, given the binomial expansions 1 minus x power of 1 over 3 in ascending power of x up to the term in x3, substitute x equal to 0.1 into the series, show that to this thing. So you have to substitute into it first. Okay, you find this value. After that, you put in your fraction. Okay, and then you change them all into this one. Okay, so you cube root it both sides, top and bottom, the numerator and denominator, and then you get this value. Okay, because the question requests for 900, right? So you have to change this one. Okay, equalize both sides. Equalize both sides. Okay, you introduce this one 100, 100, and then you get 900 already. This one also become like this. Okay, and then multiply into it, so you get this value. So you have to show the sequence. Okay, you have to show the sequence how you do this one. Show the working step. Okay, show the working step. All right. Okay, so let's see partial question. The seventh term of geometric series is 16. The fifth term is 8, and the sum of the first 10 term is positive. Find the first term and the common ratio. B hence shows that S12 equal to 126 bracket cert 2 plus 1. Okay, so you can see from here your T7 term 7 is 16, and then so T7 is actually stand for A R to the power of 6. So this is the first equation, and T5 is 8 A R power of 4 is going to 8. This power is always 1 less than the term. Okay, power is 1 less than the term. Finally, we get two equations. Then we can find the A value is equal to 2. Okay, so we put into it. Okay, 2. Since S10 is greater than 0, then R must be positive. So R is equal to cert 2. Okay. All right. So with this one, you substitute into this formula sum of 12th term. Okay. Show that sum of 12th term. You put into this one R minus 1, R minus 1. So you get this value. Then you had to change the format to be written like this as a proving. Okay, multiply conjugate. Right? So this is how you do for question number 10. Okay, I wish you all the best. Try all this tutorial. If you really don't know how to do, always can refer back to this video. Okay, we refer back to this video to help you to revise and over again. Okay, please try your best to master this idea. If you can't do, always reach for help. Okay, for guide from lecturer, from your friends, and study. Wish you all the best. Okay, thank you everyone.